customer gets with this product an application that they can download onto their mobile phone or an iPad, which they can take to the shop floor to capture the data that is attached to the non-conformance. Some of these things are physical items, so they can take photographs, video footage that they can take away and annotate and capture against the non-conformance. They can also get a web-based application, and with the web-based part of the application, the quality manager can see how many non-conformances there are in their system, the cost of non-conformance, the high cost elements of non-conformance that will bring focus to the management, the quality management organisation, but also it will enable the shop floor, engineering, manufacturing all to be communicating.
I think digital technologies or digital transformation is rife within the engineering and manufacturing industries across the board. So as the transformation has been taking place with the likes of Industry 4.0, for example, and digital twin technologies, I think the industry workforce has been upskilled to embrace digitalization technologies. One of the most exciting parts of the project is to develop the machine learning technology and integrate that within our baseline non-conformance identification product called AIRacor. So some of the challenges that we faced is looking at identifying the taxonomy that would be applicable upstream within the process itself, and then so that it facilitates the downstream analysis of the machine learning element.
So the operator will essentially be using just an application tool, an app, so to speak, and using that app they can capture what the defect is, they can capture footage, they can capture pictures, they can annotate pictures, they can send all this information through on a dynamic report, and that dynamic report can be then reviewed by a quality engineer that can be anywhere in the world. The problem that it's solving is the rapid communication of defects within your supply chain. So the product is all geared around being able to communicate information effectively between supply chains, so that when and if a non-conformance issue may arise within your facility, it can be very quickly shared between different organizations, and that they can then put some sort of corrective action in place to resolve a potentially bigger issue. Because potentially it could be a bigger problem and parts could be continually be produced with a defect in it. So it's all about, well, why can't you very quickly in a dynamic way capture what the defect is and feed that information through the supply chain to give people a chance to correct and fix issues before they become bigger issues.
One of the most challenging parts of the project is to integrate machine learning technology in quite a low data environment. Engineering and manufacturing processes are quite structured and they're quite rule-based. So what we're trying to do is incorporate that rule base and take advantage of data science, machine learning capabilities to derive intelligence from that data set whilst maintaining the integrity of that rule-based system. So all products are highly customizable. So we create a baseline AIRacor product, and our model is to have integratable modules to help with analysis, for example, or visualization of your data.
This particular project actually is a really exciting combination of a support tool for the decision-making process in non-conformances, which are an inevitable part of any manufacturing, any complex engineering operation. And this really provides a backbone of a way to slick up the handling of these, and the natural variance and stochastic inputs that come from the shop floor, with the governance, the engineering governance that has to happen at the whole aerospace product level.
Within any manufacturing environment is a lot of paper-based tools or disparate systems where data and information is stored in lots of different places. AIRacor brings all that together into one place, one single source of truth, and ultimately allows better decision making and allows you to use tools such as artificial intelligence and machine learning to make better decisions quicker. This product is a step change from that because it allows you to aggregate information over time and therefore drive better decision making through tools such as machine learning. The AMRC is built on a foundation of sharing knowledge and partnerships, and a key part of our remit, especially as part of the High Value Manufacturing Catapult, is to disseminate our projects and share them widely with UK manufacturers. So managing large data sets is an increasing challenge. Obviously, we're creating tools and systems which can capture and generate huge data sets. That can be a challenge, but at the AMRC, we've been working on techniques for how you store that data, how you interrogate that data, and how you manage it through the life cycle. Yeah, it's an important research area for industries, especially regulated industries such as aerospace, where you have to keep records for a long period of time. So being able to manage large data sets is very important.
We're really on the forefront of a change here with the application of digital technologies, but also with artificial intelligence. So this particular tool is probably one of the few that are leading the way with regards to digitalization, but also use of artificial intelligence to enable people to make decisions.
For me personally, the project is about the group collaboration between multiple people. So not one individual can deliver this project. It takes a team of people, between programmers, between architect programmers. It's a vast amount of skills and technology that need to come together to help deliver the project, and it's about coordinating and helping to deliver that solution, which is, I find, most satisfying.
I've been involved with the NATEP programme for a long time and looked after a large number of projects. It's been interesting to be part of this project with IMAGene and AMRC. As far as I'm concerned, I don't know much about the software side of a project, but I have got a manufacturing background, and it's been really exciting to see how the product has come into being and to imagine it being used by people on the shop floor. So that's really been very interesting.